everybody, it's Chris Schmidt from Rocket Lasso, and if you're watching this video when it's brand new, then we're going to be having a 25% off sale for all of the plugins that we've made at Rocket Lasso over the course of the week of NAB, so make sure to check that out. Today we are going to be talking about what's new in Cinema 4D S26. This was just announced today, and if you are watching this on the day that this video is coming out, I will be doing a live stream with Rick Barrett from Maxon in the afternoon, so go check that out. I should have a link down in the description. And I will be presenting some S26 features at NAB for Maxon, so keep an eye out for that as well. And make sure you stick around through this entire video because I'm saving my favorite feature for the very end. Now, there are a lot of features that I am excited about in this version. There's so much to cover, so let's jump right on in. First thing to mention is the plugins did not break in this version. At least testing all the Rocket Lasso plugins, they are working just fine. Once you've got them installed, I can right click and there's recall, pops right in perfectly. And under the extensions dropdown, you can see I've got my mesh to spline, Ricochet, and slicer, and they're all working perfectly without having to recompile or reinstall, re-download anything. They are just ready to roll. The next thing to mention is that Maxon One, which traditionally included Cinema 4D and Redshift, is now also including ZBrush. So for myself, I've tinkered with ZBrush a couple times through the years, but now I've got all the more motivation to dive in and really start learning those tools. And so I don't accidentally bury one of the major leads inside of S26. Every single version comes with Redshift CPU. Traditionally, Redshift works on the GPU, and some machines wouldn't be able to do that. A lot of different Mac machines couldn't do it, but now we have Redshift CPU. It is typically, depending on your hardware, not going to be as fast as the GPU, but the CPU is available on all machines default out of the box, so everybody now has a version of Redshift. If you want the GPU, you have to get Maxon One, but everybody will have Redshift CPU, and if you go into your preference folder, you can even go into the renderer Redshift, you can see where you get your different video cards, but then you also have your CPU, and you can tell it to just render one or the other, or you can even turn on hybrid rendering. Although I've been told you want to be careful with that because if your GPU is really, really fast and your CPU is significantly slower, maybe that last frame or that last bucket is going to get stuck on the CPU. And if it's running way slower, in certain circumstances, that could actually have it run a little bit slower. So it depends on your very specific hardware. Next up is the new modeling tools inside of S26. To begin with, let's take a look at the ZRemesher. This is the very first implementation from anything involving ZBrush, because of course ZBrush is now part of Maxon One. So the algorithm for the ZRemesher has now been implemented directly into Cinema 4D. So here's a pretty straightforward scene file. I've got some text and I've got a cloner cloning spheres onto the surface, which I'm then randomizing, pushing them apart, colorizing them. And then inside of a volume builder, I am feeding the text, subtracting the spheres, which I inflated a little bit. And now we get these nice bites taken out of the text. And then smoothing the overall shape so the corners aren't so sharp. And then finally, here's a cache layer. If you didn't know, you can cache the volume builder. So I'll cache that. So it's now remembering this without having to do any recalculations. And then finally, we are feeding this through the actual mesher. And because of what we're about to do, I think I'd like to decrease the poly count a bit by increasing the adaptive. And if you even just do 1%, you'll see that large areas will decrease the number of polygons. Let's increase that even more. I'm not sure how far we should go. Let's pull that up. Actually, that seems pretty decent. That's giving us overall shape. But we end up with a lot of triangles, a lot of very pinched triangles with these very complex poles. So maybe not the best results to work from, depending on if you wanted to add some modeling here or clone things onto it or run soft bodies on it. So now we have the opportunity to feed the volume mesher into the new version of the remesh. So remesh was already introduced in the last version or two, but now you'll see that the algorithm is not just based on the instant mesh, but we also have the ZRemesher algorithm. So we'll let that finish calculating, looking at all of these polygons that are making up the shape. And now it spits out a new model that should have pretty much the same number of polygons of whatever we fed in. But you'll see that we have very nice quads everywhere. No triangles. I can't find any triangles anywhere. I don't know a lot about the ZRemesher, so I'm learning this from scratch inside of Cinema. But what you'll notice using this algorithm is it's going to do a really nice job of following the flow of the model. That follows a curve and then changes direction to head down here. So that flow already is an amazing addition. You can see how this curvature works perfectly around there. We got a bunch of options inside of the tool though. First of all, just like the other algorithm, we can change it to be a very precise polygon count. So you click on that and say, I want, say, exactly 2,000 polygons, and it will output that. I'll leave it on mesh density, and we can say, you know what, only give me 50% of the number of polygons that used to be there, and it will continue to calculate. Something that's nice is a tool we're going to be talking about later, the task manager, is calculating that, and I can still manipulate other things while it's calculating. You can see now that we have much fewer polygons, but we still have that really nice curvature going. Next thing to notice is, well, we have density map. If we were to, say, make our volume mesher editable, we could make a vertex map that would say, hey, this area should have more polygons, and maybe this area down here should have less. Would be potentially pretty powerful on, say, a character, but we're going to skip over that for now and move down to adaptiveness. And adaptiveness is trying to find areas that might require more detail and give the polygons to that spot. So we already know that this area was very flat, so you can see there's very few polygons there. But over here where we get this extra detail, especially up here on the top, you can see there's a whole bunch of polygons following that curvature because it needed more detail. Cranking that adaptiveness up all the way, let's let that recalculate again. So now we're maximally adaptive, and you can see all the polygons are going exactly where they're needed. There's a lot of circumstances where this is exactly what you would want it to do. But in a lot of circumstances, especially things I would do, where maybe I want to clone onto the surface, or I want to be doing some soft body stuff on it. So I'd want a very even distribution of the mesh. In that case, I'll drop that down to 0 and let it recalculate. And just by changing that one slider, you can see that these polygons are almost all identical in size. Even around these curves, that polygon is the same as that one, which is the same as that one. So in a lot of things I do, this would end up being a lot more powerful. Now we got a couple other settings like detect hard edges, which I think is where it's going to be finding where to put the adaptive detail. You know, same with a hard edge selection. They actually put a selection tag in there. We can do symmetry, left and right, top to bottom, and then forward and back on Z. I'm not sure what it'll look like here, but let's turn on the symmetry X here. And I think it's going to end up looking pretty weird where it's taking half the geometry and mirroring it on the other side. So you'll end up with a completely different result. Like, so yeah, right here, you can see how the R is getting mirrored and it starts almost looking like an H. So this would be really powerful if you were remeshing a character who should be symmetrical left and right, but nice to be able to turn on that option. And then finally, just like the instant mesh, we have some flow splines where you could draw splines and say, hey, it should kind of be following a particular flow, one direction or another, or even putting like a helix spline around so it could spin all the way around the object and in general have that type of distribution of polygons. I'm finding this tool incredibly intuitive. Just drop your model in. It seems to calculate it just fine, and it's giving us super powerful, super usable end results. So I expect that tool to be useful not only to me, but to pretty much everybody doing anything modeling inside of Cinema 4D. The next modeling tool is Fit Circle, and this is all about manipulating your geometry to make a circle shape. Opening up this scene file, I've got a similar setup. Here's text fed into a volume builder, into a remesh, giving us a nice even polygon count. Making that editable, we can go into our polygons and select a collection of them anywhere. So let's select maybe these right there. Then right-clicking, you'll see a new tool called Fit Circle. Selecting that, click and drag, and instantly these polygons are going to snap into a perfect circle shape. This is one of those tools that when you need to make a circle on a mesh and you can't do it, it drives you crazy. So this power is very nice for a modeling tool. You'll see that we get this perfect circle. We've got a bunch of additional options. If we hold down Shift as I drag, it'll actually spin it left and right using this angle parameter. We can set the overall roundness or strength. Actually, let me grab this one. I guess actually let me hit undo and get back to the original. So clicking, I can now be in the parametric mode where I can transition fully into a circle or back to the original shape. We can set an exact radius, or we can use a percentage scale here. Then of course the spin, and we got a couple other options here, but we'll take a look at those somewhere else. Let's move over here and select those. Let me grow my selection a few times. Right click, and again, fit the circle, click and drag, and you'll see we get, again, a perfect circle, and this time completely flat on the corner there, averaging all the different angles. But we have additional options there that could be useful, say project to surface. So if I click on that, it's going to project those polygons back onto the surface so that we are pretty much maintaining that original silhouette, but now the overall selection is round. We can turn, let me actually turn off project to surface and take a look at equal spacing. If right now you'll see that the space between there and there and there and there are all nice and even. If we turn off equal spacing, then they'll jump to whatever they used to be, so we can get some longer ones and some thinner ones. So depending on the situation, it can be helpful. Select outline, we'll just convert that to an edge when you're done selecting it, and adjust Actually, I'm not even sure what adjust inner points does. Let me turn that on and off. Yeah, you can see the inside there is getting a little bit more evened out. But yeah, overall, that works great. We can now make circles on the surface for any character modeling or hard surface modeling. This works with points as well. So we could select a point there and grow, 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 and then say fit those to a circle, and those will automatically jump into that circle shape. And yeah, just working really well overall. We can continue directly from this scene file to talk about the next tool, which is the new close polygon hole mode called grid. So jumping back in the file we were just working from, let's reselect these polygons here, and then I will delete them. So those go away. So get this big hole right in the middle of that object. So hitting the shortcut for close polygon hole, which would be MD, or of course you can right click and go track down close polygon hole, which is right here, MD being the shortcut. So now you'll see that we've got a bunch of different polygon types here, and there's a brand new grid type. So by selecting grid type, I can now click to close this polygon hole, and we're gonna get a nice, clean, even grid traveling across it. No matter how many polygons, no matter what shape they are, that is going to do a great job of closing the hole. And the algorithm actually kind of works shockingly well. Let me show you. If I were to say select some crazy random polygons there, like, okay, that's a super random hole. And if I hit MD, let's go back to the original n-gon. So yeah, we could close that as an n-gon. But if we say actually close it as a grid, it's going to be analyzing all of the different polygons. And now when I click, you see that it's done a remarkable job of rebuilding that overall shape. Let's go and delete some random polygons there. And MD, close it as a grid. And boom, instant, perfect, clean sealing up of that overall shape. Even around a corner like this, delete that MD and close it up. And you'll see it's doing a remarkably good job of cleaning up the overall shape. So nice and straightforward to use, just working way better than it ever used to. And like it's just great to be able to get these bits of clean geometry. Selecting this hole again, you can imagine now that we've got that, very simple to extrude that in, and look at this perfect, clean, mechanical rounding. And because it's transitioning from that original geometry, if we just pull that in a little bit, I for inner extrude, just pull that in just a bit. Now feeding this into a subdivision surface, look at that clean, round shape that we're getting punched out of there. So combining those two tools, like very, very nice. Also worth noting is the closed polygon hole is going to do the best it can to preserve the curvature and the topology, the UVs, the vertex colors, like vertex maps, like all of that's going to try and do a perfect transition between them. All right, let's make some space and close all projects. Nope, 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 nope. Next up in our modeling tools is flatten. Keep this simple, open up a new scene file. I'll hide all of these different filters with my own preset. Create a cube. Do a bunch of subdivisions, 11 by 11 by 11 should do it for us. Make it editable, select polygon mode, select these ones in the corner, grow, 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 with UY as grow. And right-clicking, you will see another new tool called flatten. Selecting flatten, you'll see that there's very few settings, pretty straightforward tool. If I click and start dragging, you're going to see my current selection is going to completely flatten itself out based on its normals. So we've of course got our strength. We can change the position to push forward or back based on the furthest or closest point that there was originally. Use islands would be applying it to different sections. If you had different islands, like these are two different islands now. Then we've got, let me bring that back up again, flatten. There's best fit. You could also set it to the view. So if I click and drag, you're gonna see it flattens there. From our perspective, it didn't really change, but you'll see it's flattened based on the active perspective we were in. Again, hitting undo. I would like to do normal. Normal and best fit are like identical. So those are the same. Modeling axis and world axis for most purposes will be the same. By selecting that, we can flatten this based on a particular orientation. So if I say Y, it's going to completely flatten that based on the Y orientation, as if our camera was from that point of view. Hitting undo again. These all combine nicely where we can say, let's do a best fit, click and drag. And we could then reapply it and say, okay, but do it from this particular view. And now it's flattened from that point of view. And if we do a new transform, we could then again flatten it based on, say, the X orientation. And now that gets flattened there. It's going to start looking pretty crazy pretty quick, but keeping it in the world of reasonable. We can click and drag that out. And lastly, we have outline only. So as far as it fitting where it is, instead of being an average of all the polygons, it'll just look at the outline and average that. So they'll just wait it to be sunken a little bit more inside. So yeah, creating this nice flattened area. I'm gonna hit MG just to smooth out those edges. You can see we get this nice transition from one shape to the other. Really nice to have this new, very basic modeling tool. Something that when you really need it, you need it, and now we've got it. Next up in the modeling tools is smooth edges. And for this one, I would like to pop open the assets browser and find our old friend, the T-Rex. And in this one, I think we don't need any of his animation, so I'll just grab the model, delete everything else, and turn off that. Let's grab the original body mesh here, go to edge mode, and now we've got all these different edges to work from. So let's take a look at the basic idea. Selecting various edges, and the best tool for that is hitting UM, which is the path selection. Let me pause this. It's the path selection, and I like this being on live path, because now I can draw out any shape that I want, and it's going to follow exactly where my mouse goes. So let's select around this area. Let's say we want to smooth that edge out a little bit more. You see how that's finding a nice kind of center point on this pole. Let's say we want that a little more rounded. If I right click and go to smooth edges, click and drag, you can see these edges are going to smooth out relative to each other. So we get a way cleaner arc from that shape. So that might be a very practical kind of character shape one. But let's just randomly grab some different shapes from the side of it. So let me grab that, perhaps go down here. I'm just randomly grabbing these as I go. Grab that shape. Oh, let's go back and up, maybe over here, there. So kind of this weird mechanical looking shape pulled out. You see very, very geometric, very sharp angles. Right clicking, smooth edges, and click and drag. And the instant we drag just a little bit, look at how smooth and rounded that became. Especially with those edges popping out at us, you can see how organic that suddenly looks. Converting that to polygons, I'll shrink the selection by one. I guess it didn't work too well. Let me just manually select these interior polygons that we just generated. You can see we've got this nice island that's very rounded, same overall topography, but now we get this nice rounded shape inside. So if we needed to do some sort of extrusion, an inner extrude, you can see we get a lot of control over that shape. So yeah, again, these are just really nice tools to have. Opening up a new file, let's do a similar cube again. So I'll just subdivide that a few times, make it editable. And same thing, do a live path. And let's just select some kind of crazy selections here. Yeah, let's even do that. And pull this into some sort of spiral. So having done that, right click and smooth edges. Click and drag, and as we do it, look at how beautiful, look how rounded and clean that is. Doing a good job of overall keeping that original rectangle shape, but now we get all of these curves going, and I just have no idea how I would have gone about doing that otherwise, where that becomes so clean. Hitting MS for bevel, I could bevel those now and get a little bit of thickness on that edge. So many really cool opportunities again. Like, these modeling tools are... They feel basic, but they're going to open up so many opportunities. Next up is poke polygons. Jumping back to the T-Rex, flip around to the other side, and just select a single polygon right there. Right click and say poke polygon, and it's going to turn that polygon into 4 polygons as just kind of a crisscross. Opening up a brand new file, let's take a look at a cube. Set that to 5 by 5 by 5. It goes to, I don't specifically know what the usefulness of this is, except if we were doing certain dynamic simulations, I can imagine right-clicking here and saying poke polygons, because nothing's selected, it'll apply everywhere. It's kind of like a super triangulate, where every single polygon, it is changed not from cutting once to get 2 triangles out of a quad, but instead we get 4 triangles out of it. So you might get some different and more interesting simulations from it, because there's a different configuration of these polygons. Having done that, we could even feed that into a subdivision surface, and you can see that that's going to create a very different looking pattern, which could be pretty cool. Drop that to 1 by 1, and you can see, yeah, a very different looking pattern. And then I believe that there's going to be the equivalent capsule version of this from the nodes. So jumping into the assets, search for nodes, under geometry modifier, view this as a list, shrink them down. There we go, there's poke polygon, so I can drop that in and parametrically poke all of the polygons or a particular selection. So we have not destroyed the original object. We can always change the polygon count there to whatever we want. Parametrically, we've brought these down into 4 different triangles instead of a single quad. So definitely some potential usefulness. I will never scoff at another tool. Actually, there is one parameter if this was parametric or this capsule, and that is offset, where we can pull this diamond shape in or out and yeah, get a really nice diamond pattern on the overall object. I forgot to mention as we were going that a bunch of the tools that we've talked about are available as the capsule equivalent. So in addition to the poke polygons, also the smooth edges, the flatten, the fit circle, and even the ZRemesher are all available as capsules as well. Moving into our next tool is straighten edges. Back once more to the T-Rex. Let's undo that poke polygon, and this time select a couple of edges, U, M, and let's see. Let's say we want to select this line right there. Not you, but you. We've got that edge selected. Right-clicking, there is now a setting called Straighten Edges. Selecting that, I can click and drag, and that selected edge will average out and evenly space every single one of those polygons. Hitting undo, let's create a series of those, UM, and select that one in parallel, and this one in parallel. Let's even do that one. Oops, not there. And there. So we got all those different edges. Right click and straighten edges. Click, and each one will independently calculate and straighten out. So a perfectly straight line from the start point to the end point, and that automatically creates even spacing in between each one. So not very many options in here, but you don't need them. Like, this is very straightforward. If you need certain edges to become straight lines, we can just right click, straighten edges, and those become a perfectly straight line. That is just another amazing tool to have in the toolbox. And there is the parametric version of that as well. And then so many modeling tools. And then we have an improved bridge tool. Into a new file, I'll create a cube set to 11 by 11 by 11 again, making it editable. Hide a bunch of the filters. Into polygon mode, I would like to make this a little playground for us. So I'll select that outline, that one, U, F, fill, grow, delete. So now I've got top, side, and bottom here to play with the new and improved bridge tool. Hitting the letter B for bridge, you'll see I have no polygon selected. But with nothing selected, I can select any given polygon and drag it to any other, and it will bridge between them. We can instantly create as many bridges as we like from one side to another, even between these two pillars that we made. Like, those can get interlinked. So very quick to make some combinations that way, nothing selected. Hitting undo a few times. Now we can select some of these. So let's say I select 4 of those and 4 of these, B for bridge, bridge between them. Undo. I will intentionally link that from one corner to the equivalent. Instead, I will offset. I'm going to hit the wrong one, but you'll see it's going to intelligently figure out what the best combination would have been. So those got properly interlinked. These do not have to have even sizes. So I can have 8 of them selected, 4 down here, B for bridge. Again, link them. It will properly combine them. But of course, they can be properly combined. Let's make 4 by 4 there, B for bridge, interlink between them. And yeah, this giant connection. Now we have a couple of settings that we can play with. Something like subdivide, which will create subdivisions in between. And then spin steps, increase the spin steps. And what's going to happen is that one is not connecting to its direct equivalent. It's stepping down 1 per step. And we get this nice twist going on. Now, in order to see this a little bit better, how about we select a polygon in the center, grow, grow, grow. Then turn these into circles with our fit circle. Drag those out. There we go. Perfect circle. B for bridge. And again, interconnect them. And perfect bridge in between. So with this still live, of course, we can create as many subdivisions as we want. But then there is a tension control. And I can change this tension to pinch these polygons in the center or more near their origin. But that's in normal mode. Instead of that, let's change this to surface. And now you see the entire thing is going to scale in or out. We get a nice barrel shape just from that instant bridge connection. Very nice shape. It would be a little difficult to make with other tools. Then there is surface average. I'm not entirely sure what this one keys off of, but you're going to see that it's going to curve way over to the left side or the pinch to the right. And there's a flip to the opposite side. Then we've got normal average, and that is, what is this one doing? That one seems to be pinching again towards the center. Different bridges here will behave in different ways. This time we're doing a giant cylinder, which is going to behave differently than a set bridge. Let's say if I selected those two and those two, B for bridge, connect. Now we get this nice twisting bridge there. And the tension will probably behave decently different here, depending on what mode we're in. Yeah, pinching those in, inflating it out. A lot of different options there. Okay, hitting undo a few times. Go back to this shape, and I would like to, let's delete out a sizable window here. And then go back to bridge tool, B for bridge tool. If we are in edge mode, we can directly drag any edge to any other edge. And, ooh, I didn't know it did that. That's cool. Because of the subdivisions, you can see it's actually closed that out. Let's see what happens if I connect that one. Oh, wow, look, it's connecting. It's continuing to connect those. I did not know it did that. So by changing the subdivisions, it's going to follow the curvature of the one that it saw on the other side. So that's pretty cool. Putting this kind of back to default. And I'm not sure what default is here, but if I connect those, this is what I was expecting. I could get this direct connection between them, just being in edge mode. Subdividing, let's see, actually, let's undo that and do that connection. And now let's subdivide. Oh yeah, and we got this curve here because I have all this curvature. So yeah, I can still pinch that and pull it in one direction or the other. And then continuing that, yeah, that will link them together. So that's pretty cool. Hitting undo a few times. We have additional options like patch mode. If we turn on patch mode, it will continue to try and do those connections. And let's see, let me pull this down, and you see that it'll actually close the entire hole there, going from one side to the other. And it's actually viewing from one side to the other. By doing this, you can see that it saw that there should have been a subdivision and a subdivision and a subdivision, and it did create those. Now, it didn't know how to subdivide as it went on, across. So we get these triangles going. And yeah, we can say one-sided patch. So as I click and pull down, it'll pull the polygons and continue that pattern just from the one side that it was matching. And you can see I was able to close that hole up again. Selecting all of my polygons, select all, MG for iron, and let me drag again and again and again and again and again. And now I've got this crazy rounded shape. So selecting this and making a kind of crazy looking hole here. Actually, yeah, let's do something like that. Deleting. You can imagine that using the bridge tool now, based on that same, let's see, what do we have? Yeah, edge mode, sorry. In edge mode, we are in patch mode. Actually, let's just do patch mode. And if I connect from one side to the other, it's going to attempt to close the entire thing, and it does an okay job of it. So because we've broken that, let me connect from this side there, and it perfectly will close each of these based on the row that came before it. And I'm able to patch this up manually, and it looks pretty good. I don't think that quite closed. Now, let's see if we can do it from there. Yep. So yeah, that actually works pretty well overall. I'd want to make sure to weld that corner. ME is probably a good idea to drag that and weld it. And now back to B for bridge, and now close that up. And I guess I only weld one side, so let's go back to a regular patch and drag that across. And okay, made a little triangle there. So ME, pop that edge. So yeah, bridge tool opening up a lot more opportunities. One last thing that it can do, delete this, and let's create two different spheres. So here's a sphere, and copy paste, move this one over here. Make them both editable. B for bridge, two completely unrelated objects. Let me grab polygon mode and say, I want that polygon to link to this one. And we get let me get rid of our tension. Let me connect that polygon to that one. And instant bridge between those two. Grab this polygon to that polygon. Instant bridge between those. And all of the modifications, well, not all. If I select this one, you can see that it created a bridge because that's where I dragged it from. And if I select this one, it created it from here. And it should have created the hole in both models. So if I zoom in, you can see that they have bridged in spite of being two unrelated objects. So yeah, the bridge tool has opened up a lot more opportunities. Just like the other tools, it also has it's doing its best to maintain the normals and the vertex colors, vertex maps, and the UVs. So yeah, nice and improved bridge tool. The last two modeling tools let's introduce at the exact same time. One is the equal spacing, and the other is going to be the set flow. And I'm bringing both of those up at the same time because I'm going to kind of use them interchangeably. I think they pair really well together. Into a new file, let's clean it up, create another cube, and this time let's do, I don't know, another 11 by 11 by 11. Why not? It's been working out for us so far. Another couple loop selections. So I want a loop and a loop this time. UF for fill, select, grow, delete, and now I get one wall of 11 by 11 and the floor. 11 by 11. So we want to do the bridge tool again. So B for bridge. Let's connect one corner to the opposite one. I would like a bunch of subdivisions, so let's pull those out. And should we put some tension? Yeah, why not? Let's add in some curvy tension. It's not going to look great because it depends on the mode that we're in. We can try pushing these further. Yeah, I don't like that one given this scenario. Normal, average, that one looks super crazy. So I guess the surface was giving us the best one. Oh, that's just making it larger. So I guess normal was the best. Okay, so that kind of gives us elbow shape. We'll make a couple additional bridges. Let's make a nice, fun, round one. So let's select these 9 and these 9. Right click, circle, and B for bridge. Link them together. Let's create a set of 4 to a set 4 bridge. And let's see, grab a tall one, 3 by 3 bridge. And what else do we want to do? Let's make, here's an idea, bridge, and I'll do a single bridge and another single bridge, and then bridge between, nope, not those two. Let me get the proper angle here. From there to there. Okay, so we've bridged across there. So a whole bunch of different bridges. Now, to the new tool. I would like to go to edge mode, and we're going to have to take a second and select a whole bunch of edges here. So forgive me. I will fast forward here. Okay, a whole bunch of different bridges selected. Let's right click, and inside of here, we've got the two tools we were talking about. One is our set flow and the other is equal spacing. Let's begin with equal spacing, selecting that and not changing anything. Let me click and drag, and you'll see, especially as I do this, yeah, actually, no, it maintained that original curvature, but now look, they are evenly spaced perfectly between each other. There's the same amount of space from here to here, from there to there, to there to there, and including on the bottom. Hitting undo, let's look at that again as I click and drag. 100%, perfectly sharing their overall space. And yep, now that is stuck there, just automatically working. The only alternative option we have is setting it to linear. So now as we click and drag, it's going to set these to also be losing their initial shape. So they get evenly spaced, forming perfectly straight lines, even spacing everywhere. Hitting undo twice. Let's move to our next tool, and that is set flow. This one is going to be respecting the overall shape of the object. We can get some curvature going as well. So with set flow, I can click and drag. I think it's going to look a little bit crazy. You see those aren't working too well, but that's because we want to set a maximum angle. And as I click and drag upward, we're going to see those pop. And I'm going to go really high all the way up to 180. Hit undo, because now when I click and drag, you see that these are going to space themselves out into this really nice transition between the two. But now we have additional options as far as the tension is concerned, so we can blend between those. We can also change to edge mode, and this is going to maintain more of that curvature. And you see we get a nice rounded version. You see how we get this nice clean arc now overall? There's equal spacing, which should spread those out evenly again. Linear is probably going to kill the curve off. Yeah, that just becomes a straight line. There's also normal mode, which is going to look a little bit crazy given this particular circumstance. I'm not sure where I'd want to apply that one most. Keep in mind, I don't think this curve is because of what the already existing one was. In fact, why don't we set this to equal spacing and hit apply, and now those become perfectly straight. Move into set flow, so this is just based on this, and now as we click and drag, that I can add this curvature back in again. Changing the fallback to edge mode, I can click and drag, and we should get nice even spacing and that nice clean curvature, like these really nice arcs where it's kind of referencing the angle where the origin was and the angle where it's going, and creates a nice smooth transition between those two. Even including over here, get that nice even spacing on those as well. So yeah, that is the set flow and the equal spacing on the edges. So you can see how this combination of all of those tools, from ZRemesher to fit circle to bridge and the set flow, all these tools are going to open up a lot of opportunities for more advanced modeling inside of Cinema 4D. And it's super crazy that there are capsule versions of all of these as well. So that concludes the first major set of features inside of S26. Into a short but new topic are improvements to the vector import. Now I'm going to pop open R25 for a moment and pop open this file from my friends over at Loose Keys. And let's take a look at this. If we zoom up, you can see that we got a couple issues. The hair didn't fill in, and you see this little flying robot guy, and he's got a whole bunch of extra shapes going on. And that's because in R25, it couldn't handle clipping masks. But if we jump to S26 and drag that same file in, let it import, you're going to see that not only does this hair pop in, but the robot came in properly with the different clipping masks. And another neat feature that was added is there's a Create Materials button. So if I open up our material window and click Create Materials, it is going to create a equivalent material for every single different color. If you make this editable, you will see that we have a whole bunch of different objects, and the different objects have different base colors applied to them. So now it would have made those materials and applied them, and those are all trying to get rendered now. But it's created all those different materials automatically, and in addition, instead of just working with Illustrator files, it also works with .svg files, although I don't have any handy to demo. Next up is a series of rapid-fire details about tweaks to the interface. The first one to notice is they brought back the green check marks. In 25, you'll see that these were actually gray, but now we are back to them being green, which I approve of. That is excellent. Next, I'm going to tweak my layout here. Click on nodes, modify this to show, I like showing the assets browser by default, jumping into operators, maybe even going into geometry modifier, list, and see it shrunk. So let's say that's a new default. I want to save this as a layout. Click the plus, save it as a layout, and I shall just call it nodes plus. Hit save. You'll now see that when I create one, it is going to be called nodes plus in italics, where if I jump back to 25, you'll see that every time I made a custom one, it would be parentheses user, which ate up quite a bit of space. So I appreciate that eating up not as much space. In addition to that, all of these can be rearranged merely by clicking on them and dragging them to a new location. Let's jump back to standard. While sticking with tabs, if we right click on one of our files, we now have the open recent all showing up in this list. So we can immediately pull open one of our other ones, and that will open up that file. Next up, if you go File Open or Control or Command O, it will pop open your file manager. And now we can select more than one file. In the past, you can only select one. Clicking Open, all of those will open, all the documents up on the top, and they will very rapidly open, and they are getting processed in the background through the new task manager. It shouldn't stop you from continuing to work while a file is opening. Imagine opening a giant CAD file, and that could still be processing in the background while you're working on something. So another great addition via the task manager. Close up all of those open files. Okay, moving into the objects manager and the attributes manager, the first thing to notice is these tabs up on top look a little bit more like buttons. I think the point of that was supposed to be that they've been doing these radio tab flyouts, and it's supposed to stop confusion between those two systems. So these look a little bit like buttons. That took a little getting used to me, but I'm used to it already. And then, while being a very tiny thing, I think it will be important in certain circumstances, especially if you're working in a real world scale. They've expanded the decimal place by an extra 1. So we have horizontal spacing. In the past, the smallest number you could do would be 0.001. That's as small as things could possibly get. Well, now you can put an extra 0 there and get even more precise. Next, I don't know if this has happened to you, but you're going to scroll. In fact, let me jump to R25 so I can talk about this better. You move your mouse over here and you're like, okay, I'm just going to scroll my wheel because I want to get down to more parameters. So as I scroll down, you'll see that the numbers will start updating instead of the attribute manager scrolling down. So you have to kind of carefully position your mouse to make sure you're not changing parameters as you scroll. And it can get really crazy if you moused over the wrong thing. You can change modes and like everything could change. You never know. Jumping into S26 though, if I am moused over this and I try and scroll, nothing will happen. The only parameters that will scroll up and down is if you've clicked and highlighted it. Now that this is highlighted, I can scroll up and down. Click on this one, scroll up and down. But if it's not selected, if nothing's selected, then you are just free to scroll up and down, and this menu isn't tall enough to require it. So if I scoot that down, you can now see that no matter where my mouse is, it scrolls up and down. Will definitely save me a little bit of time for accidentally scrolling on the wrong thing. Super tiny, jumping back to 25 to demonstrate. If we select two of the same object, and so let me select one, change a value, and select both, you'll see that it says like multiple, all this, kind of nonsense there. And you can select that and change it inside of 26. If we select more than one thing and they have different numbers, you'll see it says mixed, just a little cleaner. And it doesn't look like it's flying off the side of the screen. Also, I suppose of note is the little, I don't even know what you call these, but these little arrows to tick the value up by 1. Those aren't visually there to keep the interface a little bit more clean. You have to mouse over it and you'll see them appear. So it behaves exactly the same, but they're hidden normally. Hit undo and get that back. Next up is something that's pretty handy is we can select text. And when we go into the font menu, up at the very top, we're going to get a font filter. So if I wanted to search for lemon, I can get my different lemon milk fonts and they pop right up. Instead of scrolling through your gigantic category of all your fonts, you can jump right to exactly what you want. Definitely, I will be using that a bunch. Super tiny one, creating a null. Under shape, they now have a little icon that goes along with it to tell you exactly what the display type of the null will be. And now we move into the preferences menu, where when we go to the plugins or asset browser, now, actually, let me show you in 25 to compare. Inside of the preferences in 25 and before, if we click add folder, it's going to open up this like terrible Windows folder, which always drove me nuts. It's so hard to navigate that. But now inside of 26, when we click add folder, we get the lovely regular file manager, which I very much appreciate. Sticking in the preferences menu, go down to the material tab, and you'll now see that we have a new viewport preview default size. So there was always a default texture size, but you never quite knew what that was. Now we know exactly what it is, and we can set it to any number. So if your material is very large, when you create it by default, it's going to have a nice high resolution by cranking this number up to something larger. And that concludes all of the little interface tweaks. And now we move on to the task manager. In previous versions of Cinema, we had this status bar down here. This would give us information about different tools, different objects. It's great if you would mouse over something. It tells you what the tool is, a little description of it. It'll tell you the shortcut. In this case, Shift and F will be the go to start button. And if you moused over an object, it'll say not only the name, but the object type that it is. Well, that system has been expanded into the task manager. Now, right now it's blank. If I click off of it, it's going to disappear automatically, but I can click and say, stick around with this pin. Now, what this is going to do is certain processes that take a bunch of time to calculate and process will be logged here, and we can do them asynchronously. The best version of this that I can think of is loading in CAD files. So to give us a baseline, let me open up R25, and I'm going to drag in 3 different CAD files. You can see the number 3 there, drop it, and now it wants to figure out the import settings. So I'll say, okay, and now we're going to wait. It is now calculating that one file. It takes forever to import CAD files, so we don't know how long this is going to take, and we just have to wait for the process to finish. Depending on the file, those can be huge. It might be taking like a half hour. It might be taking an hour long for that to load. Now, it's asking for the second one, so presumably the first one finished, so we could finally say the second one. But that would mean that we'd have to be probably doing something else. You see that we've kind of got the beach ball here where we're just waiting for it to process. Okay, the third one's come in. I'll say, okay, that one's going to be calculating. We don't know how long this would take. We'd be probably tabbing away, working on some other project, and then coming back, and you don't know when that's going to be finishing. There we go. Finally, that is finished, and we've got all 3 files open. Let's move into 26 and look at the same thing. As I drag all 3 CAD files in, I now get this menu, and I say, okay, and it popped up again. I'll say, okay, and that's going to cover both of them. And now we have 3 files all loading in. We get this counter for exactly how long it's been processing so far. It tells us at what time this started, and all of them are processing in parallel. This is the exact same way that you can open up multiple scene files. Now the first one has finished, and you can see that's loaded up, and I'm able to start manipulating it. I can change the camera, I can start working on it. Oop, there, the second one finished, it automatically opened up, and we could change that, manipulate it however we want, be working on other scene files as we go. We can be jumping in between scene files. So that's all still open to go while it's continuing to process the last and largest one. And there we go, that one finished, and that pops open. As soon as one finishes, it will be the one to pop open, which is, we can easily jump back to wherever we need to. And it's a nice way of indicating that, yes, that has completed. So right there, huge improvement. Now, this isn't limited to just CAD files. You saw earlier, we were able to load up a whole bunch of different scene files at the exact same time. Actually, let's even open them up again. I'll say open, and here's that menu. Let me just grab a bunch of these title cards and say open. And you see instantly all of those have been queued up, and they load in so quickly, it's not even a second long, and all the information has updated. Easy to now close, 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 close. And we'll just close all of those files up. And let's see, back to this point. So yeah, having those be asynchronous and not having to all happen at the exact same time, really opening up opportunities there. In addition, this does some helpful things inside of, say, the asset browser, a couple different things. It's supposed to make it so that loading up certain databases is going to be way quicker. There's also another concept inside the assets browser, which, let's see, I've been told, I've never run into this personally, but I've been told if I click on this filter, you can see all these different menus. So like here's the Rocket Lasso assets browser, and you can see that I've kind of got my own personal one. Let's find that under objects, and somewhere here, yeah, there we've got Rocket Lasso, and you can see, I've got my dice, and I've got my gemstones and a bunch of different types of pasta. If you imported like a giant collection of models or a giant collection of materials, I've heard it can take a really long time for those to load, because when you open up Cinema, it would be indexing all of them. Well, we can right click on something and say create database index, and that will create an index for that collection, store it, and now when you open up Cinema, there is no load time. It's just going to reference that one later whenever you need it. So that would also be running through the task manager. And I never work off of a network, but I've been told that if you save a file, it will actually save it locally and then start transferring it over the network instead of you having to wait for it to sync up with the network before you can move forward. So this should improve a bunch of workflows across the board, and it's something that you don't even need to know is happening. It's just going to be happening in the background, and it's enabled a whole bunch of things to work way smoothly than they would have in the past. Up next are two very small additions to the rigging tools inside of Cinema. One is called Hammer Weights. Opening up this character file, you're going to see, okay, we've got this mesh, we get this character. If you've done any rigging, this is the type of thing you're going to run into. By selecting the face, I can go and click on the weight map. I'll double click it so it pops open. You can see all the different weights. And there's one point that's just not quite working right. This could be because you added in some new joints or you forgot to have one selected as you applied all of them. There's a lot of ways that this type of thing can happen. So going into my point selection, I will select that one rogue point. And holding down Shift, I'll double click on this and it'll pop open our weight manager. So here's all these different weights, and we see all these different information. Under commands, we've got all these different tools, and one of them is the new hammer. So what does hammer do? Well, selecting hammer, we can say apply selected. And what that is going to do for us, as I click it, it's going to ignore any information that is currently on that point, look at all the other points around it, and adapt to that. So hitting undo, you'll see it's 100% stuck to joint L3B. When I click apply selected, it's going to look at all the ones around it, and you see lots of different colors. And now joint L3B isn't there at all. And we are just attached now to like the upper lips and the nose and the eye. So all the appropriate things that were directly around it. So unlike a very similar tool called Smooth, Smooth would be looking at itself as well, and it would be really hard to erase out that one aspect. But Hammer just completely gets rid of it and adapts the ones around it. So that is a nice little addition. And the other rigging tool is this Colorize Joints tool. So popping open this little demo. So here is a skeleton I have put together. You'll see that we've got the main spine, but then we've also got the left leg, which I have named L period. And we got a bunch of limbs on the right, which are R period. Right click on rig to select all the children. Under character, we'll go to command and you'll see a Colorize Joints. Clicking on that, it's going to pop open a menu. We can now track down the different joints via the prefix. So I will say capital L period, and the right one will be capital R period. And then we can also say colorize other. Now, what is this going to do? It's going to find everything that is based on the left and color it blue, everything on the right and color it red, and then every other joint that is not part of this, it's going to color yellow. So we could customize these to any colors. Typically, I would make the ones in the middle a green, but hey, if yellow is a good standard, then we can leave it there. And it's currently saying, hey, only look at the joints, but if you turn that off, it'll colorize all of the objects, not just the joints. So let's hit OK. And just with a single click right there, we have now colorized all these individual joints via changing their basic color and their display color to be this set one. So two nice little workflow tools, not super crazy, but a nice addition nonetheless. Now let's move into talking about the new features in Redshift. As we briefly mentioned earlier, Redshift has been way more integrated into S26. And if you have S26, you automatically get the CPU rendering for Redshift. It's not going to be nearly as fast as your GPU. And to get the GPU, you need Maxon One. That unlocks all the GPU stuff. And the two can even render in a hybrid way. But let's talk about some of the specific new features here. I would like to begin by opening up this scene file. This was made during one of the recent live streams from Rocket Lasso Live. If you are not already following, I do a live stream on Wednesdays for 2 hours where I take questions live from the audience. And you can follow along on Twitch or on YouTube. If you're not already following, you can go to youtube.com/rocketlasso and you can check out the older videos, different plugin videos, and all sorts of tutorials. And there's also a link to the Rocket Lasso Live archive page where I post the replays of all of the previous videos. And this one was made 2 weeks ago. It was really fun. We got to use a little bit of Ricochet. In any case, let's start talking about some Redshift. By default, you see that we've got our default sky, environment, all those, and we've got our regular Cinema 4D lights. But let's shift this into Redshift mode, and you do that just by opening up your render settings. And inside the render settings, we've got the default renderer, which is standard, but now everybody will have a version of Redshift. And the instant I click that, you will see that this menu has changed to Redshift items, and the lights have changed to Redshift lights. So that immediately is setting us up into this new mode. In addition to those objects, we can open up the material manager, and if I just double click, instead of a regular Cinema standard material, it will make a Redshift material. And this is going to be node-based, the newer nodes. It's based on those, but actually I think we'll almost never be using this Redshift material because there's another new material. You click on this plus, go to Materials, Standard, and this is another Redshift material, but it's built in a way, the architecture of it is way more of a universal standard. So it's going to be a little bit more similar to the way all different renderers and different packages work. So I definitely recommend using that as your default. Now, if you are really hung up on the old Espresso style, you can always go into your preferences, click on renderer, Redshift, and turn off node material presets. And then if you double click, now you get a Redshift material, but when you double click on that, it'll pop open the Espresso style ones. But in my opinion, there's not really any reason to go back to that. Everything works in the new setup. We've got some new power and advantages in the new style. So let's leave it on the new version. By double clicking on that material, let's take a look at the new layout. This should be a little bit more simplified, a little bit more intuitive, and as I said, a little bit more universal in the way that this layout is. First of all, we've got a new metalness workflow, which is really straightforward. Why don't we actually apply this material to the letter R? So that is now got this applied. So the metalness workflow is really straightforward. Pretty much it's like, hey, is this made of metal? 0. Is it made of metal? Yes. Let's crank that all the way up to 1. And so now that is metallic, and that's pretty much all you have to do to it. And then you can set your roughness to be super shiny or really rough. Nice and straightforward. Scrolling down, we've got the same things. We've got our transmittance, which is transparency and subsurface scattering, sheen as we've had. But now there's a new thin film, which is pretty cool, which will start working right away just by modifying this thickness. And something important to note, the thickness is in nanometers. And when you look up what a thin film value should be, it's always going to be in nanometers. So if it's supposed to be 300 nanometers, type in 300 into that. And as soon as that updates, we should get that to refresh, and immediately you see we get that nice thin film, kind of that iridescent look traveling across the entire surface. So very nice out of the gate. And we've got our coat that we can put on top of that. Here is the emission or luminance on top of it. Down here we've got the bump, all of it in one giant line, very straightforward. And of course you can still go into advanced, change those settings, and everything's lined up ready for you to go right there. But you can go further with it by, of course, going into the node editor. You can click on the node editor to pop that open, and you'll see this standard Redshift material node right here. It's got everything that we're looking at, every setting is stored right here, and then ultimately the final output goes out to the surface. So a couple nice things here right away. The most important nodes that you'll use all the time are already exposed. We got color and the metalness and the roughness of the metal or the plastic, things like the bump. Excellent. All those are definitely things that we want. But let's say we want to control something that isn't there. Let's make a Cinema 4D noise, and you can double click and search for the word noise. And there we've got the Redshift noise or the Maxon noise. Drag this over. And what do we want that to control? Well, I could drag that into one of these existing ones, but I can just click and miss all of those, and we'll get a giant list of all the different things we might control. So here's emission, and that's what I want to control is the color of the emission. So done, that will just work. But let's get rid of that and say, instead of manually tracking that down, there's a new shortcut to get to that. On every single one of these properties, there is a second circle. And if we go and scroll down to, let's say, the emission, let's give it some weight, so there will be some illumination. And look, instantly you see that illumination in the viewport. But we want to control the actual emission color. Hold down Control or Command as you click on that circle, and it will pop open the node material. It will automatically create that input and highlight it for you. So now very easy for me to know exactly what to plug in. Instantly that should be feeding through, and even better, look at that. We can see the noise pattern coming straight through in the viewport. In fact, this viewport has been updated to show tons of stuff with Redshift. It should be working really well as long as you're using these new nodes. So what does it cover? The diffuse, reflection, the roughness and the weight, all the IOR stuff, the bump and the tint, the emission, transmission color, metalness, sheen color, the bump, of course, the coat, normal maps, bumps, all the Maxon noises, MoGraph user datas, like all that stuff will translate through into the viewport for you. So very nice to be able to actually see the viewport, because I'm sure all of you are used to having to turn off the textures, turn off the materials, and change your shading type to something really straightforward. But now we can actually see what it looks like. In addition to that, we've got some additional options I'd like to mention. Let's simplify this let's delink the emission, put the emission down, because I don't want any of that. And now inside of the node material, let's talk about another node that is pretty important. In the past, we had the material blender node, but there's a new and improved version of it. And you can find that by searching for the word layer. And here you'll find a material layer. And it has changed the way it works a little bit. This only takes two input, the base layer, and that would be this standard material. Let me show you. So here's an entire material encapsulated. And let's say that we're going to blend two different ones together. So this is a nice kind of shiny iridescent metal material. I'll duplicate that by holding down Control or Command. And in this copy of the material, let's change it to be a nice simple plastic. So no more metalness, and set that to a nice bright yellow plastic look. A little bit of diffuse, make it a little bit rougher so it's not so shiny. And I'm not sure if a thin film is appropriate for this plastic. Depending on the plastic, maybe yes, maybe no. You can see I've got this nice clean yellow plastic now. So using this material layer, I would say that this nice bright one, that will be the base. Actually, let's do metal as the undercoat. So we'll drag this metal in as the base layer, drag this nice plastic one in as the secondary layer, and that's going to completely override it. But we can now mask it out using something like, let's say, the noise. So that will now be the mask, and we'll output that as the final material. Now the actual mask won't show up in the viewport, but if we pop open our render view, Redshift render view, and turn on the IPR, and now we can see those two materials. There's the metal underneath and the yellow plastic on top, each running. Now it's not going to look very good because we only have one material going. This mask is not very contrasty, so let's jump into that Maxon noise and set it up a little bit better. Let's close out some of these windows. It's difficult to do this recording on one monitor, but here is the noise. Let's change the noise type to something a little bit crazier. Let's do Luca. That always has a ton of contrast going. And scroll down. Let's make the input. So you get the input. We can increase the scale to be larger, and then go down here and crank up the contrast so there's not too much blending between the two. And that should now be updating and controlling that material layer. Well, let's do a refresh on the IPR. See the new version, creating the mask here. And yeah, way more contrast on that. Now, this, of course, would look a lot better if we had some sort of lighting going. So let's temporarily pause that, move this over to the other monitor. And let's create a Redshift light. So let's go and say, okay, I would like a dome light. And the dome light, of course, creates a big giant dome over the scene. And you can see a little bit of illumination already. Something that's nice is we can go into the asset browser and search for the word HDR. So type that in, make sure you're in all, and you'll get some materials that use HDRs. But I want to scroll down here into the actual images. And here's a bunch of different HDRs that are already installed inside the assets browser. So dragging this into the texture field, you can see that that HDR has been applied, and instantly that overrides like the global one. And that is now what we're seeing. Let's drag this one over. So we get a nice shiny outdoor scene. Collapse that down. Now something's a little bit more illuminated. Pull this back over again, turn back on our IPR. And now we've got an environment where we have a plastic material over a metallic material. So that is the material layer as well. Now, something I'd like to show, which is very important. Let's open up another file here. And I've got a bunch of dice models that I made, and 3 different materials. We've got this metallic one, some plastic, and some glass looking ones. And of course a dome light and a couple different lights in the scene. And this is currently set up with the old style of materials. And what I want to talk about is the old materials would lose energy as they got rougher, as they were more blurry. So showing you that by popping open the render view. Let's start that up again, and we will see these, and they're looking good. We got some nice copper here, we got the plastic, we got the glass, and we don't have to let this resolve for too long. We'll just do a little bit. The thing to point out here is how bright that is and how nice and clean and transparent. But as we work our way down the line, each one is getting a little bit more blurry. It's getting more rough. And you see how dark this glass got, and especially this last copper dye, it got very dark as well. Sending that picture to the picture viewer, we'll store that so we can do an A/B test later. And let's give that a pause and swap this over to the new material. So those were the old Redshift material. Let's shift those over to the new standard Redshift material. So I'll just swap these two over. And what's great about this, let's reactivate the IPR, is there's way better energy conservation. So even here at a glance, look at how much brighter this one is as a piece of copper. And look how much brighter this one is as glass. So just let that resolve for a little bit more. And there's no difference between those materials. I just rebuilt them in one material or in the new standard material, and it started looking way nicer. Click to send it to the picture viewer, give that a pause, and now we can take a look at these, and I can go and A/B these and look at, nothing's changed. Like, look how similar they are at the beginning, but then when we get to them being way rougher, you are maintaining that brightness. So yeah, energy conservation, big plus overall for your renders. Glancing at my notes, it looks like I only forgot one thing that I wanted to mention. So let's pop open the material manager and open up a material. Let's say the new plastic. And that is, in our diffuse model, there is a new model that you can use, and it's called the D-Eon, or maybe Dion Lambertian spheres. And what that's going to do is a great job of things that need microfaceting. So imagine things like ground, where it's very rough, and it should be rough all the way down. So that's going to be a very good model for doing that. I don't have a specific demo for it, but if you got something rough, switch it over to that one. That should wrap up everything I want to mention about Redshift. Now let's take a quick look at a couple of little changes inside of the scene nodes. We're not going to spend too much time here. There's a couple of things here that are not going to be applicable to too many people, so I'm not even going to really touch upon them here. I'll probably end up making a dedicated video about scene nodes and a lot of things that I've learned, but now is not the time to go diving into a whole bunch of scene nodes because we had other features to talk about, and we still have my favorite feature to talk about. So I'll double click and search for the word matrix because I would like to find the transform vector. And it's a quick example of before we used to just have the word matrix and just vector, but now you can actually explode out the vector and control just the X or the Y or the Z. That saves a bunch of time. And the same with the matrix, you can twirl that down and see the individual components, where before you had to feed in an entire matrix. So that's a very nice addition. There were some tools added to make splines a little bit more controllable, but none of those are going to be applicable to anybody unless they're already deep in the nodes. And like I said, I'll save that for a dedicated video. And lastly, a bunch of the geometry modifiers that we've talked about, the new modeling tools in Cinema, also have their equivalent inside of the scene nodes. Things like the poke polygons can now be brought in as some procedural nodes you can make your own setup from. And that includes everything from the equal spacing and fit circle, flatten, poke polygons, set flow, straighten edges, smooth edges. So yeah, all of those are included now as procedural nodes, which makes things powerful. I am excited for the future of nodes. Rocket Lasso gave a whole bunch of notes to Maxon while we were doing the consulting for them over the break from the live streams, but none of that stuff would be able to be integrated anytime soon. But they were really, really open to the feedback, so that was really nice. So nothing else really to talk about as far as nodes. We already talked a little bit about some of the other features. By going into the material layout, I could select this and go to any one of these settings, holding that control as I click on something like the direct scale, control or command click, and now that automatically pops out so it's easy to connect to. That's actually a huge addition just from a workflow standpoint. But keep an eye out in the future for some dedicated node videos. Back to our standard layout, close all of our scene files, and get ready for my favorite feature of this version of Cinema. And that is the new unified simulation system inside of S26. I am very excited about this. I have barely gotten to scratch the surface, and there is so much potential for this system. Now, specifically, the unified simulations are covering cloth and rope so far. And even within that arena, it has opened up a lot of really cool possibilities. As a little bit of a framing device here, we're going to step through a bunch of the broad strokes here. But if you want to get more in depth on this, I'm going to be doing a presentation for Maxon at NAB. And if you go to 3dmotionshow.com, you can see the current schedule. Scroll down, you can see the different dates. And if you jump on over here, you're going to see that I have a presentation on Monday, and that's going to be entirely about the new simulation systems. And we're going to be going super deep, making crazy projects. So this will be a broad strokes overview of it. In addition, I suppose I should mention that I'm going to be doing a live stream today, right after this video goes out, with Rick Barrett from Maxon. We're going to be going over a whole bunch of stuff inside of S26, answering questions for 2 hours from the chat on YouTube and Twitch. You should head on over there. I'm going to have a link to this below in the description. So I look forward to seeing everybody over there as we tackle this. So the point being is you're going to be seeing lots of S26 content from me in the future. All right, moving back into Cinema, let's open up this scene file and take a look at some basics. What do I got here? Well, we've got a plane set up as the ground, a couple subdivisions in there, a text object, which I will feed into a volume builder, into a volume mesher, into a ZRemesher to get a nice even and low poly count. And then let's add on some tags. Right-clicking on the plane, we can go Simulation, Collider, and on the remesh, right-click and say Simulation, Cloth. Now, one thing you'll probably notice is as I'm right-clicking, simulation menu, this isn't what used to be there. What happened to the soft body? What happened to the rigid body? Well, those have moved up to the bullet tags section. So it's a separate dynamic system. It's not part of the unified system. Then all of this is dealing with cloth and rope. So that's what we're going to be sticking to today. Okay, with these tags applied, all the defaults set up, I will just hit play and we can see those fall to the ground and start bouncing around. So a very, very nice start there. Hitting pause and rewind. This system is entirely based on particle dynamics, so it's going to behave differently than some of the things we've seen in the past. While we're looking at the tags, there'll be a lot of familiar settings from things like soft body and things from the old cloth, but this is a completely new system that has no real relationship to the stuff that we used to have. So let's step through a couple of the basic settings here and see what we're dealing with. First of all, we saw them fall. They're bouncing just fine. Very nice. Let's do some bendiness. Set bendiness to 11, which should definitely show us some sort of result. Hit play and boop. Oh, you definitely see these fall over and they're way bendier than they used to be. Let's rewind and instead try some stretchiness. Jump that up to 11 and see what we get. And squish. And yeah, way bouncier because now they're allowed to stretch instead of constantly trying to maintain the length in between each of these different points on the object. They're allowed to squish a bit. Reset that back to default. We have bounciness. Bounciness, depending on situation, isn't going to do too much. Let's jump that to 1, which might be 100%, which means when it hits the ground, it's going to be trying to maintain that energy. But because it's a squishy system, much like soft bodies, you're going to lose that energy quickly. If we try putting up to 2, I'm curious what the actual level is because at a certain point, you're adding more energy into the system than it's taking out. And you'll start seeing things get pretty crazy. I'm not even sure what the limits. Oh, okay, definitely push that up to the point where it started exploding. So 15 is definitely adding energy. Put that back to the default of 0 by right-clicking on the arrow. Next up is friction. That's going to be really straightforward. I don't think we need to turn it on. It's going to stop them from sliding over each other. Thickness, very handy where we can inflate different objects. So we can add a cloth NURBS to it and add thickness to, say, a sheet that's being blown over something or possibly clothing on a character. Next up is mass. That's important for things being heavier or lighter as compared to each other. And then we have quad diagonals, which is if it's internally subdividing. So those are some nice basic settings. Let's have things get more interesting by twirling down this balloon setting. This balloon setting is going to be similar to rest length in the soft body, but it's very different. If I turn this on, it has got a setting called overpressure, but really it's just how much pressure is there in this. 1 means maintain the current pressure. So if I hit play, I don't think it's going to be very visually different. It will be a little bit because it's trying to maintain its volume. And you can see them, yeah, definitely maintaining their shape a little bit more before they fall over. Let's rewind and change this number up to 2 and hit play. And what do we get? Oh, okay. Now they're definitely maintaining their shape a lot more and they're inflating. Look at them taking on this like more rigid shape and bouncing around even more. Now, there's another setting here called expansion time, and that's really important. If you remember rest length in some of my old tutorials, when you would change rest length, you never wanted to just change the value from, say, 1 to 2, because suddenly it's trying to inflate to a new size really quickly. So they were really clever where they added in a setting, which is enabling it to transition. So it's essentially going from 1 up to 2 over the course of 30 frames. So it has some time to expand. That means if we can push this further, like 5, it has 30 frames in which to inflate to this insane size where we're super inflating these up. If we rewind and we say, okay, but do that in 5 frames, it's going to possibly explode. Let's hit play. And yeah, you see they go huge very quickly. But we can do the opposite. Let's start under pressuring this by setting it to 0.5, so half of its original volume. Hit play, and we'll see those start to deflate as they don't have as much air inside, and you see them collapse down. Very different look. And even now I could jump that back up to 1, hit play, and we'll see them reinflate a bit to their original size, and again taking 30 frames to get there. Now you can under pressure even more, but I think you want to be careful. If you go to very small numbers, I've had it kind of get a lot of energy and kind of explode. So let's do 0.1 and see what happens. So over the course of 30 frames, yeah, you can see that somehow there's some energy in the system where things are flopping around in extra ways, and I don't have a good intuition for slowing those types of things down. So just use it as a cautionary tale of those are trying to fight each other as they deflate. And there's a good chance that's because there's low pressure, but then the overall springs that are keeping the points relatively far from each other they're saying, well, I want to stretch out. And then the balloon is saying, yeah, but I want you to pull in, and there's energy being gained there. But I don't know for sure good solutions to that yet. We'll be definitely playing with this some more in the future because I've already got some fun ways of using this. Actually, we'll see that just a little bit. Next up is plastic deformation, where you can bend an object, and once it's bent a little bit, it sort of breaks. It gets stuck in that new position. So let's turn that on. And at the same time, I've heard that's a good idea to, if you're going to do bend deform, you also want to do some stretch deform. So the springs don't fight each other. And I'm just going to give it full strength. So if it bends more than 10 degrees, it's going to be stuck into a new position. So I don't know how much these bend, but let's hit play. You can see them bounce. Okay, not too much of a change there. So let's say that the bend can happen quicker. And deform past, I'll say almost anything, 101%. If it stretches just a little bit, that becomes its new permanent size. Hit play, and yeah, you see the 2 from its own weight kind of broke, and now that's stuck, bent over. Let's push this even further by adding in a bunch of bendiness and potentially stretchiness, and hit play, and now we'll see them scrunch over and immediately take on this shape, and they're just like, okay, this is my shape now, I'm going to be stuck there. So plastic deformation, very powerful. We'll be doing a lot with that in the future as well. Next up, very exciting, we have tearing. In order to simplify this a bit, let's just change this to an S. So we only have one piece of geometry because I'd like it to have more polygons on a single object. We'll jump this up. Then we go further than that. Let's do 75% of the original polygon count. Yeah, that's looking pretty good. And you'll notice that my adaptiveness is set to 0 because I wanted a very even polygon count all the way around it. Having done that, we can now go to tearing and turn that on. Tearing, very similar to the way cloth used to work, but it's way better with one key difference, although it's got extra things beyond that. Let's see if we can set this up pretty well. Let's do 101%. So pretty much if it bends at all, it's going to tear. And let's turn off this deformation. So if we hit play, I don't know if this will work, but I'll hit play and see what happens. As it falls, you're going to see we definitely get some tears going on in there. Let's turn off our polygons, and you can definitely see that this is broken a bit. Let's rewind and add some balloon. So I'll turn that on and say, I want you to maintain your original pressure. And let's say you'll tear if you go past 110%. And hit play, and we'll see that fall into the ground. And again, it's breaking, and it seems to almost have popped. You can see where there's some different tears in here. Where you can see this being different than the old tearing that we used to have is polygons aren't suddenly disappearing. When there's a cut, say along a seam, instead of both the polygons disappearing and us ending up with less surface area, it's being maintained. Now, let's see if we can push this further by over-pressuring a bit. I'm going to go double the pressure, and I'm going to do it over the course of 5 seconds. Let's see what happens. Hit play, and immediately you see it inflated very quickly. And because it inflated, it tore. Look at these tears that we got inside the model. That's getting interesting right away. Let's push that even further. I'd like to turn off gravity, so Control D. We haven't talked about this yet, but there are now simulation settings and there are bullet settings. Bullet settings are the settings from the older system, and those look identical. And now we have simulation settings, which are different. They're largely similar, but there are some key differences that we will be talking about. Also, super important to note, we haven't gotten to it, but this can run on the GPU. In fact, by default, it does run on the GPU, but something about my computer's current configuration, it doesn't like the GPU, and it's been giving me trouble. So I set mine to CPU. According to some people I talked to, my computer seems to be an oddball case, and I'm looking forward to getting it working properly because the GPU should be working even faster. Anyway, you see the gravity right here, so I'll turn that gravity off, and now without gravity, we can turn off the plane, and this is just floating in space now, so now we can just inflate it and see what happens. So currently it's inflating over the course of 5 frames to double its original volume, and you see, boom, it pops, kind of wiggles, and essentially I think those are almost like air holes in it now, so it doesn't have to further inflate. Now let's push it further. Let's overinflate by 5 over the course of 5 frames. Hit play, and look at that. You see over the course of the first frame, it's suddenly inflating, and the next frame, it tears. And look at all these wonderful tears we're getting inside the model, perfectly along some of these seams. So that gives us the opportunity to look at some of these other settings. And you see that our other settings like bendiness and stretchiness are trying to return them. Oh, but it's continuing to tear, which is kind of neat. Yeah, look at this thing just rip apart. And we have a very small tear percentage here. So you can see that as this bends, it's kind of free to continue tearing. But man, look at that. That's so cool. So yeah, that's overpressuring. We're tearing at a certain percent. Let's push that a little bit further. We can even go pretty high, like 155, because over the course of those couple frames, I think it will largely still get an opportunity to tear. Let's see. Yeah, we got some tears, but it's returning back to the original shape. So I would like to, let's start combining settings. Under our deformation, we'll say that once it kind of bends, it's allowed to stay in its new bent position, in its new stretch position. And let's say it's very bendy at 15, very stretchy at 15. And yeah, that should do it. Let's hit play and see those explode. And that rips. It's maintaining the shape and wobbling around, drifting away. So let's push that even further. I want that to inflate. Let's inflate faster over the course of 3 frames. Okay, you see even that little difference there by it being not even twice as fast. You see how much more it tore because of the relative forces we were applying. And because now it's got plastic deformation, it should mostly be remembering this new shape. It's still kind of a little crazy as it's got a lot of energy as it's bouncing around. But yeah, it should be stuck in a more bent shape. And it's not going to tear too much more because it has to bend beyond 155% in order to be able to tear some more. Although it seems to be doing a pretty good job of still ripping itself apart. You can keyframe these parameters so we could push that even higher so it wouldn't want to tear after, say, the 5th frame. And then we've got tear guiding. And let's see, what do I like to do? Let's slow the tear down significantly and put the tear really low, maybe 102%. And I don't have an intuition for the tear yet. But you'll see right now that we got a nice clean tear here, one along that seam, one along this one. Not a lot of curvature, like maybe 2 of those combined. Let's try setting tear guiding to 0 and hit play. And we're going to see it. Actually, in this one, not too many tears, but here you see almost one continuous one. Let's make it tear more, inflate over the course of 10 frames. Hit play. Not too much tearing again. We'll go even faster. We got to get some tears going. Okay, that one really broke. Let's do it frame by frame. Explode, tear, and let's see what the tears are doing. These very much still, to me, feel like they're traveling along the lines, but I could be wrong. So let's try doing the opposite. I want to do a tear guide as high as it will go, and that goes up to 90. Let's see what that does. Rewind, frame forward, and let's see what we got. Well, we got a lot more lines here. This one, I feel like if we go higher, I'm not certain, but if we go higher, I feel like we're more free to do little turns, like little twists and turns as it goes. And this definitely has more of a shredded feel to it. Hitting play will, oh, it kept on exploding, not surprisingly. We have, it's tearing very easily. So let's put that back up to something a little bit higher. Play, tear, explode, pieces flying all over the place. But yeah, you see we're maintaining that overall surface. So there's a lot to continue exploring here. To add some of the other settings that we had, something like that parametric poke tool, the polygon poke tool, let's go into the asset browser and search for the poke. And here's the poke polygon. If I drop that under the remesher, and I'll move it below just so it's got the proper calculation, what's happened now is we've kind of like triangulated it, but in every direction. So this mesh has become a lot more complex where there's a lot more directions that the tear might be able to travel. And it's all parametric. That means it's all already updated. There's a lot more polygons now, so it might run a little bit slower, but let's hit play and see if that's going to grow. And yeah, super shredded. I guess we should probably calm that down a bit. Let's put this back to the default of 45 and say it has to go to 155% to tear. Play, and we let that rip. And yeah, it shoots out, and now, of course, it's recoiling back inward. Let's give that a second, and let's see what some of our tears are doing. Yeah, they didn't crisscross too much. Yeah, you got to find those very specific settings to know for sure. I think I'd like to drop the tear down a bit lower, and I think the tear guiding at 0, maybe that will enable it to do some more interesting breaks. Yeah, okay, that looked pretty good. Let's rewind and go frame, and now we can see some tears that are cutting some corners and creating some more interesting cuts along it. So yeah, a lot of possibilities there. Now we're using a pre-built shape here. It's a, it's a full volume of a mesh, But we could be tearing lots of different things. We could be tearing cloth as we drop the sheet, and then we can also be tearing things like rope, which is a good transition into our next scene file, which is this one. I have got a helix spline, and the helix spline is over a bowl. The bowl is pretty straightforward, where it is just a simple loft, which I bake down, put into a cloth surface to give some thickness, and then do a subdivision smooth just to round it out a bit. I think the original collision should happen in the connect object, so that will be my simulation collider. And then let's start out with the helix. So I'll right click on that and say simulation rope. So just applied the rope. Now, without changing anything else, Control D, some of these settings might be not default. So let me make sure they are default. No, I think they're pretty much default. Let's hit play and see what we get. And what we should get is, well, let me show you. I've got a giant, super tall helix here. So hitting play, we should see this helix begin to fall into this bowl and fill it up. A little bit difficult to see, so let's rewind and activate this connect object and this sweep. So now we actually can see something. So I've got this set up as some sort of noodle. Hitting play, we can now see that fall into the bowl, and it's filling it up quite nicely. By default, let's take a look at what we've got. We've got a radius of 0.5, some stretchiness, some bendiness. There's a setting called curly. And then we got like the overall mass and tearing on it as well. But let's kind of step through this, see what we're looking at. First of all, it looks like these are passing through each other quite a bit. So let's hit play, see how they settle. Yeah, they're definitely passing through each other. The end side is currently saying that they have a radius of 5. So definitely let's increase that radius to something larger, like 5. And hitting play, let's see if it, yep, you immediately see they bounced away from each other. Oh, and look at that. Look how these are already overlapping on top of each other. Let's rewind all the way and hit play and see if that falls in the bowl a little bit nicer. And yep, we're getting some noodles, and there we go. Excellent, nice, fast pile of noodles in the bowl. Now, clearly you can see I've got a cloner set up here. So let's activate that cloner, and now I've got a bunch of noodles all set up and going way up into the sky. Let's move that simulation tag up to the cloner, not the individual object. I think cloners won't see the tag as a child, so you apply it to the cloner itself, which is different than the old rigid body stuff and the old soft body, where we want to apply that to the cloner, and now all the children will be fed that tag. In fact, it's probably seeing them all almost as a single spline, and they're each calculating. So let's see how this runs. Hit NA, and let's even turn on our SSAO, and probably even some shadows. And now we can see them have a little bit more collision. Immediately, some of them were intersecting each other, so push them away. And now we've got this giant pile of noodles all dropping into the bowl, filling up, looking, oh, that's looking so good. And it's running really well. Like, look how many different collisions must be happening for this to fall. And it just keeps coming. There's more and more noodles. Finally, they all fall into the bowl. And now they are slowly settling down. Awesome. Exactly what I would be hoping for. Look at these not intersecting, all flopping out over the bowl. Running really well, really smooth. Very, very pleased with this. And keep in mind that my computer is being forced to run on the CPU, so this probably would have run even faster in a different situation. Rewinding all the way. Let's do a simplified version. I'll copy out that sweep, delete that tag, turn off these noodles, and let's make a brand new spline. Let's see, what should we do? I mean, the helix always works really well, so let's make another helix. Do it from scratch, lay it flat on the ground, pull it up. I like having very direct control over how many points there are, so inside of the helix, I'll say intermediate points, none, and now I know there's exactly 100 points. Have it spin around times 2, so it's 1,440. A bit taller, a height of maybe 500. There we go. And now I can drop that into the sweep so we can actually see it properly and make it editable. And I do that because we can right click on the helix, add a rope tag, and now select a point. So in this case, how about selecting this endpoint right there, and then say, I would like that endpoint, now select your rope tag, to be fixed. So fixed set. So that is now a fixed point. Hitting play. Now the entire spline will fall away and down, and we should probably set the radius up to 5. This spline will now fall down into the container, but that endpoint is still stuck there. Let's turn off the container, and we'll see that entire line just fall away, in fact, uncoiling as it goes, and perfectly form a lovely rope for us. And now let's push these things a little bit further and move the duplicate over, and let's spin one of them, so that should actually properly tangle them up. hopefully. In fact, why don't we just make another one? Why not? Spin it again and move it again. Now, each of those independently has its own fixed point still. So hopefully those are all decently tangled up. Let me turn off the rest of that hierarchy. Now hit play and watch the lines fall. A couple of them were already intersecting, so now we see them fall. And you can definitely see them interacting and pulling against each other. Let them keep on falling. And, oh, very nice tangle going. I like tangles. Hit play. Oop, yep, there we go. They all tangled up perfectly. You see them trying to pull through each other. And all of this, very impressively, working from the default settings. We have not, in any of these tests that we've done so far, we have not changed the global settings in the simulation. Controller Command D. And we have tons of settings in here, like our overall scene scale, our substeps, which behave exactly like the substeps we used to have inside of Bullet, which was the expert steps per frame. So substeps are the exact same thing. So right now, it's almost like every frame is being divided up into 20 frames. So I could say actually double that, more than double that, up to 55. And now there's way more calculations going on, which means it's going to be way more accurate. So we can let that play through. And there's very little going on, so this is running in pretty much real time. And that knot is still doing an excellent job. But we have additional settings, like how many iterations there are. So instead of subdividing the entire thing by, say, 55 different times, we can do iterations, which means run the simulation twice. And then we have things like smoothing iterations. Some of these I don't fully know what they do, like smoothing iterations. And then there's collision passes, which is important if two things are passing through each other. Post-collision passes, and then polish iterations. A lot of these I don't have a good artistic understanding of yet. I should by the time NAB rolls around. So let's crank this up. In fact, let's do an extra collision pass. Why not? I'm not sure what a polish iteration does, but let's turn all those on and see what we get. And I imagine it's just going to be a cleaner simulation overall. And that knot's doing a great job. Nothing's passing through each other. And yeah, actually it's straightening out pretty well. And yeah, ending up with that same tangle. But anyway, the point being is it was looking really great even with the default settings. But I think it might be time to push this even a little bit further than we have in a brand new file. Let's create a radial of some splines. So let's pop back open our friendly helix spline. Set the radius to 0 by 0, no intermediate points, and get rid of all the rotation. And now we have a spline that's exactly 200 long with 100 points. If I were to feed that into this cloner, I can say, okay, I would like it to be a radial of a radius of 0 and create as many of those as we want. 10 should be good. And I'm thinking, let's just throw that into a connect. Make it editable, and we should have a bunch of different splines. These are, maybe they're extra subdivided. Hit undo and make sure, yeah, that's set to none. We don't need that many points. So let's set to 25 and make that editable. And now we should have a series of disconnected splines, each doing their own thing. So with that in mind, if we select the outermost point, in fact, here's what I'll do. Control or Command A, select all. UK to shrink your selection once, which will also deselect the one in the middle. Invert UI, and now I've only got the outsides selected. And with the select tool, I can say, don't worry about visible only and erase out this middle one. And now I've got the outer point selected, just a kind of a shortcut for doing that. Right click, add on a simulation rope tag, and I would like to fix all of these current points. So I'll say fix those. And let's go into the overall simulation settings. Control D, simulation, and I'll set my personal computer to CPU, just so that's working a little bit better. And now if I hit play, we should see all these individual lines just fall down and settle, being almost identical to each other. Now we can play with another tag called the connector. Under simulation tags, I want a connector tag. For now, I think we only need to change one setting, and that is don't worry about other objects, worry about the same object, and click create without changing anything else. Now, when I hit play, all of those lines are actually stuck together. Each individual line was allowed to do a search radius of 1 and find up to 3 connections to make. They all got welded via this connector tag. So that is a great way of instantly combining all these. And you can imagine starting to make some very advanced different configurations by merging things together this way. And yeah, those lines working great. We can make as many of those as we wanted to. But now I want to go and combine this with a couple of Rocket Lasso's plugins, which I had no idea these tools were going to exist, and some of our tools work awesomely with it. So just to show you a very quick example, we have a tool called Mesh to Spline. Open up a new file, and we should do this quickly because we are already getting pretty long in this video. Let's change the preset so that I can hide all of this background stuff. I'm going to paste in the lights that we've been using. Hide those so we don't see them. And let's turn on some lovely SSAO and the shadows. Okay, let's create a cube shape. We need some subdivision, so I'll say 11 by 11 by 11. And I'm going to be using a Rocket Lasso plugin because even though we had no idea these tools were coming out, a couple of our tools are working really well in combination here. So with our cube, I would like to feed that into our plugin, Mesh to Spline. If I hold down Alt, Mesh to Spline will become a parent of the cube, and it's going to consume the cube and now return a spline instead. We're not going to go into all the settings here, and you could just make the cube editable and say edge to spline if you want to do the equivalent. But I'm going to change a setting to say don't do the Cinema 4D edge to spline algorithm. Instead, explode every single one. So every single different edge has been exploded out. Right-clicking on the mesh to spline, let's add a simulation rope. Don't change any settings, and let's make a sphere. Shrink that down a little bit and say, okay, sphere, I would like you to be a collider. Now, without changing any of the settings inside of the rope, if I hit play, keep in mind these are all exploded segments. So when I hit play, you're going to see all of those just shatter and fall away. So we need to connect those. To do that, of course, we can use the connector tag. So add a connector. It is currently going to look at the same object. We'll turn on, turn off other objects, search radius, and it can make up to 3 connections per different line. So with that done, actually, let's jump it up to 5 because maybe each line wants to make a connection with each neighbor. That should do it. So I'll say, go ahead and clear the current connections, make a new one. And without changing anything else, let's hit play. And hopefully, yep, we can see the cage fall and stretch and look at this instant net that we're getting. Now, it is passing through this object quite a bit, so we might need to do a couple of subdivisions and some changes. But first of all, let's change the rope to actually have some thickness. I'm thinking we jump this up to 2. Let's give it a bit of friction. And so we can see it better, let's feed that into a sweep. And into the sweep, we'll also add an end side with some extra subdivisions and a thickness of 2. And then something that's smart is with a sweep, you can always turn off the caps to make it run quicker. There's a lot of different caps that get generated, and they actually take the most amount of time out of everything the sweep is doing. Now we've got this big cage, and when we hit play, we can see that's going to fall down, hit the sphere, and the entire thing is stretching and behaving like a giant net. You can even see it stretching pretty well. So just by adding a little bit of friction, that actually worked pretty well overall. Could probably use a couple of extra subframes. So let's go Controller Command D, simulation, and let's double the subframes, the substeps, and maybe a couple extra collision passes just to make sure that it's not sneaking through. So with that done, hit play, and now the cage will fall down, and we should get way more accurate. And yep, that is doing a great job of sticking together, and now we've instantly got a completely parametric setup. And we've got this great net that's ready to fall over the entire object and have it do whatever we want via all of these connections. Now to push that a little bit further, well, I don't want to go too far on that. So yeah, let's call that one good and turn it off and make a different rig entirely. And let's see, what's a good way of setting it up? Let's make another letter. So I do love that new workflow of creating some text. And let's use a bunch of new things that we've learned. Let's put in the 26 and change our font, and we'll search for lemon, and let's do medium on that one. Set this to the middle. Feed that text into a volume builder, which goes into a volume mesher. Looks like it could use some extra resolution, so I'll jump that up to 5. Grab the mesher again, feed that into the remesh, which is set to ZRemesher. And now we can see we get this great flow traveling along the entire thing. Get rid of the adaptiveness, so I have an even polygon count, kind of going all over the place. And let's add some extra depth to the text a little bit. And now we'll use another plugin. Like I said, I want to talk a little bit about the opportunities that these plugins added. And you know what? I'm going to shrink these together. Let's put a little less horizontal spacing because I want them barely to intersect. So now that that's happening, let's create a Ricochet. And this Ricochet is the ability of kind of shooting a laser and having it bounce on geometry like it's some sort of mirror. So if I feed this into the model, and then in Ricochet, I'll say, hey, go ahead and let's delete the other one. Let's say that this should be fed a object, and the object will be the remesh, and instantly see that line disappeared. But that's because if I hide that geometry, you can see that we've got this laser bouncing around inside. So I can increase the length and we get a bunch of bounces. But I can say, hey, give us even more. So I'll say 10 times as many. You see that fills up a lot. But now let's do 10 times as many again. And you see it gets super crazy filled, but still really fast. So that opens up lots of cool design opportunities. But in this case, we don't want that crazy laser bouncing around quite that much. So instead, I'm going to take that and scoot it. Let's go to the top of the number 6. So it's right there on top, slightly above. And then inside of Ricochet, we've got some awesome settings for adding some like shell thickness. So here's the shell. And by setting the shell up to maybe 1, let's jump that up to 1 and turn on visualize. You can see that there's a little bit of a space in between those two that our line can run. So if I do successfully trap our laser in between those two, then what should happen, actually, let me offset this by 1. So now you can see all those points are on the outside, meaning if the laser gets trapped in between those two walls, we will now be seeing something that's traveling around the perimeter of the object. So let's not visualize, and you now see that this line is kind of crisscrossing all over these numbers. So let's go back to the main tab and increase the length. And here is some surface alignment. So we'll crank that up. So now it's going to be following the curvature of the object. And we're getting these really nice wraps jumping around there. And we got some randomness if we want that to bounce around a little bit. And let's increase the length a bunch, maybe up to, say, 5,000. And now we can change the seed. I can click this randomize seed button and we can keep getting different bounces until I have a layout that I really like. And let's see, that one's looking good. Nice even distribution overall. So even while this is parametric, let us right click on it and say, I want that to be a simulation rope. And then we've got our overall mesh. I'll right click on that and say that would be a simulation collider. And by itself, let's see what happens. First of all, this is going to have not a very even point count. So let's just see what it ends up doing. We can go into the spline tab and say enable that and then set that to, yeah, we could say linear, but then set that to a uniform distribution, which might give us a somewhat even point count. Set that to a uniform of 1, hit play and see what kind of simulation we get. So we got a bunch of lines that are probably intersecting each other a bit and the mesh, but then yeah, you see them pop away and now they are just drifting down. The friction is stopping them from falling away. And you can see that all of these lines are now drooping perfectly on the model. Like, I love that so much. Let's rewind a bit. That's nice and tangled. I do like that. And let's say that the rope has a little bit more radius on it. And that could be fed into a sweep. And again, fed an end side. Give it 12 sides. Give it a radius of 2. I guess that's actually pretty thick. So let's drop that down to 1 and a radius of 1. And so with that in mind, you can see the distribution a little bit better. And it's not perfectly evenly subdivided. And our upcoming tool utility splines will solve that, but that's not quite out yet. So let's change the color of this just so it jumps out a bit. There we go, nice bright pink. And let's see what we can get that to do just by hitting play. So we've got all those lines and they should kind of pop out from each other because they've got those individual radiuses. And so it's going to kind of explode because they were intersecting. But now they drift and you see it's trapped and wrapped around this model so much that they don't even want to fall. So yeah, I don't even think I need those connectors here. Just letting these run and do their own thing is doing a great job of just having them get tangled and wrap around this object. Again, opening up some like this never would have run anywhere near this fast before. And you can, I'm trying to imagine how I would do this otherwise, but instantly we get this perfect string wrapping all around it. And Ricochet just enabling that to be created so quickly, along with these amazing new simulations that we can do. Now, obviously, we are just barely scratching the surface of what these can do. There are entire tags that we haven't talked about where under simulation, we've got things like the cloth belt. And even inside of, let me just put a regular cloth on here. You can see that in this cloth, we have the dressing settings and we can do caching. We could be adding different forces in there. Lots of additional things we have not even gone into. Every single one of these settings has the ability to have a vertex map fed through, and these don't link a direct vertex map. It actually takes in the name. So in theory, you could be feeding it vertex maps that were parametrically generated and might not even be exposed yet. Maybe they're made by Neutron, so they can see those as well. As I mentioned, I'm going to be doing a live stream in just a couple hours with Rick, and we'll probably be covering a bunch of this stuff. And then next week, I'll have an entire presentation just covering stuff about this new simulation. And you can bet that I'm going to have like multi-hour tutorials on all the different details because you probably know how obsessed I get with dynamic systems. So I will be diving deep, figuring everything out and trying to make it in a nice digestible form so that everybody else can make awesome things from it. Thank you so much for watching this video. If you found this video helpful for your ability to kickstart using S26, if you use it for convincing your boss that you need all the newest, latest, and greatest features from Cinema 4D. If in any way it was helpful, then please consider supporting me on Patreon. Even just a few bucks a month goes a long way for making us have a nice, stable income so that we can focus on making tools and plugins and tutorials and live streams, answering people's questions. So instead of taking on client work, we can do that type of thing. So any amount is appreciated, and you get all sorts of bonuses and perks and early access to things and special discounts. Speaking of discounts, keep in mind that the week of NAB, there's going to be a 25% off all of our tools and even the gemstone model collection over that week. So if this video is new, make sure you check that out. And if you're watching this when it's super new, in just a couple hours, I'm going to be doing a live stream with Rick Barrett, talking all about the new S26 features. And you can talk to Rick to get like the deep inside information on exactly what's going on. And in a week, I'll be doing a presentation for Maxon, talking all about more of the features inside of the simulation stuff. So once again, thank you so much for watching. Thank you for all your support, and I'll see you in a future tutorial or live stream. Bye-bye, everybody.